Hello, this is Miss Klippner with the video lesson for Monday, February 7th. The essential question is, how can we use addition or subtraction to solve an equation? Take out your planner and write down the homework 7.2b. It's a BIM. And then if you haven't taken the Chapter 3 test, even if you're at home, you can log in and take that. We are going to have an assignment tomorrow that goes over some of the questions from the Chapter 3 test so that you can learn from your mistakes. Okay, so I'm going to skip the warm-up. That's for you if you're at home, just for fun. You can check out the answer key in the note section of Canvas where I put the answer key to the notes. All right, so here we go. I'm going to ask you to just follow along and see what you think about this. Let's do some math magic. Okay, so I want you to think of a number, write it down, maybe do mental math. Then I want you to double it. Okay, then add 10. Then take half of your number. Then I want you to take away the number that you started with. Your number is 5. Every single time you pick a number, it should end up with 5. And I don't want to tell you the reason why yet. Okay, here we go. Let's do some notes. So this says preface. The purpose of the next several lessons is not just to see if you can find the value of the variable. It's to introduce you to the structure that exists when solving equations. You will need to pay attention to the process as well as checking the solution to an equation. How you replicate that structure is what you will be graded on, right? So look at this first student that knew that x equals 3. Cool, it's great. That shows me that they know how to count up from 7 and go 8, 9, 10. The answer must be 3. But now, and that's great. So I give you some points because you figured out the missing number. Now, this student over here did something that was really cool, and they drew this balance scale, and they subtracted 7 from each side. Okay, so this example is different from what's on your notes. And then they figured out that x equals 3 is the solution, and they plugged that number back in, and they checked it to make sure it worked. I know it seems kind of silly, but I'm setting you up for 7th and 8th grade when you start solving more complicated equations. Okay, so this is not on your notes. When solving equations, it's useful to visualize the equation as a balance scale, or like one of those balance puzzles where things are hanging. And you can this time picture the variable as a mystery bag filled with gold. And you can put weights on the opposite side to determine the weight of the bag. So if I go like this and I put one weight, let me do this and make a little clone. Okay, so right now x equals 1. If I put a second one on there, now I'm saying x equals 2. And if I put a third one, I'm saying x equals 1. But then what if I do this? X plus 1 equals 3. Well, what I'm going to need to do is I'm going to need to take 1 off of this side of the scale and 1 off of this side of the scale because I need to get that mystery bag all alone to figure out what it weighs. That's the idea for today. Okay, so here we go. How do we find the value of the mystery bag? We isolate the mystery bag. So isolate means to get it all by itself on one side of the equation. So what I can do is I can remove one of these from the left side, but then to keep my scale balanced, I remove one from the right side. Okay, so let's first write the equation that matches this. So down here on the equation, I am writing, see I have the mystery bag of x, plus I have 2, and that's equal to 1, 2, 3, 4, 5. So you're probably already thinking that I know the answer is 3, but I'm showing you the process that we're going to use is we're going to take up 1 from the left side, 1 from the right side, take another from the left, take another from the right, and that's what shows me that x equals 3. So here's what I want to do. I'm going to write x plus 2 equals 5. And what I'm going to do is I'm going to draw this balance scale is right where the equal sign is, and I'm going to take 2 away from the left side and 2 away from the right side. And notice that this positive 2 and negative 2, it cancel each other out. And I put a circle around it because it's actually called a zero pair. Because if I have a positive 2 and a negative 2, they add up to 0. And then all I have on this side is the x, but what I have over here is the 3. So that's my solution to that equation. All right, let's do another one. So now this time I have, see how you have 4 on this side? So my equation, I'm going to write it over here just to give me room, is x plus 4 equals, well, there's 5 plus 5 is 10. So what I'm going to do is I'm going to take, I need to get the mystery bag by itself so that I know what it weighs. So I want to remove any of these 1 blocks that are on the side with the x. I look at the side with the x and I say, okay, I'm going to take away 4. I'm just going to take all 4 away, which means I'm going to take 4 away from the right side. And when I subtract 4 from both sides, here's what it looks like in my equation. Oops, I didn't want to highlight, but that's all right. So I'm going to do a minus 4 on the left side and a minus 4 on the right side. So what you see, that matches my picture, is x equals 6. Okay, here's another example. Whoa, wait a minute. This time the variable is on the right-hand side, so that's kind of freaking me out, but I think I can handle it. I'm going to write the equation just as I see it. I'm going to count 5, 9 plus 2 is 11. So I know this equation is 11 equals, now I've got the x plus 5, but the 5 is first. That's okay. So I've got 5 plus x. All right, so you know I'm going to look at the side with the variable, and I'm going to need to take 5 of those pieces off. So I'm going to take 5 from the right-hand side, which means I'm also going to need to take 5 from the left-hand side to keep the scale in balance. So I do that, and then I go over here and I go, well, now let's see what it looks like with just the equation. I draw the balance scale down, and I subtract 5 from this side, and I subtract 5 from this side. And I want you to notice that I put the minus 5 underneath the positive 5. Now, I know it's a positive because there's no negative sign. I could put a little plus there to remind myself. That's a positive 5 and a negative 5, and that's a 0 pair, and it cancels out. So all I have on this side is the x, and what I have over here is 6. So I know that the x is equal to 6. Okay, so the property that we've been using is called the subtraction property of equality. It says when we subtract the same value from both sides of an equation, the 2 sides remain equal. And I want you to know that all of these problems that we looked at were addition problems, right? It was addition, so I have to use the opposite of addition, which is subtraction. And the opposite is called an inverse. And inverse operations undo each other. So addition and subtraction are opposites, they're inverse. So the idea is I could take 1 away from here and 1 away from here, and 4 still equals 4. Or I can add 2 to this side, and oops, I forgot to take away from there. So let's see, I have 6 equals 6, right? As long as I add or subtract the same amount to each side, my scale is going to remain balanced. Okay, so here's some OYO. I want you to pause the video, try these OYOs, and I'm going to show you, remember with the check? With the check, you're always going to write the original equation. So right now, I can write this because I know this is how you're going to check your solution. You have to find the value and then plug it back in. Okay, so now, hopefully you've paused the video and you're going to try these on your own. All right, so I'm going to draw the balance scale. I'm going to look at the side with the variable, and I know I want to get rid of 6 of these little cubes, so I'm going to subtract 6 from both sides, and I put an underline, and I do the math. 9 minus 6 is 3. 6 minus 6, there's my 0 pair. That goes away, so I know y equals 3. And if you want to change it and put it like this, I'm okay with it, but I'm also okay with you writing that. Okay, so now when I check, I'm going to rewrite my equation. I'm still going to draw the balance scale because I'm going to check to see if the left side and the right side are the same. I'm going to plug that 3 in, and I'm going to do the math just like we learned how to do last week. And if you end up with 9 equals 9, cha-ching, I put a check mark. I know y equals 3 is correct. If you get something that's not equal, then remember what I said, your solution is wrong, and you have to check your math. Okay, putting the balance scale down, I'm going to subtract 3/4 from this side and subtract 3/4 from this side. This is a 0 pair that cancels out. I end up with G equals. Now, I'm going to change the 1 and 1/4. I'm going to do the addication, where I turn a mixed number into an improper. I multiply and then add in the 1. So I end up with 5/4 minus 3/4. And guess what? That is 2/4. Now, I need to simplify the 2/4. I know G equals 1/2 because I know 2/4 is equal to 1/2. But I'm going to keep it as 2/4 when I plug it in to make the math easier. So I'm going to take that 2/4 and plug it in for G. So I have 2/4 plus 3/4 equals 1 1/4. Now remember, you can't stop there. You're not giving me an equation. Sorry, I don't want you to let me do the math, right? I want you to do the combining and say that 2/4 plus 3/4 equals 5/4. And then I know that 4 goes into 5 one time, and I have 1 left over, so it's 1 1/4. So that's how I get 1 1/4 is equal to 1 1/4. You have to do all the math to prove that the left side and the right side are equal. Okay, so here we go. So now what do we do if we have equations that have subtraction, right? Well, again, we're going to do the opposite. So now what I want to do is I want to look at the side with a variable. I'm going to write the equation. This is now a -2. So I have x minus 2 equals 2, 4, 7. So what I'm going to do this time is I'm going to add 2 to both sides. So I'm going to put positive 2, the cubes, and I'm going to put a positive 2 here. And now these -2 and positive 2 cancel each other out. So all I have on this side is the x, and I know that x is equal to 9. But you might have already been thinking, hey, what number, if I take away 2, equals 7? Probably you were thinking 9, but I'm going to show you with the equation. I draw the balance scale. I do the opposite of subtracting 2, and I add 2 to both sides. I do the math. That's a 0 pair. They cancel out. I get x equals 9, right? Okay. Let's see. Okay, so now we're using the addition property of equality. I'm going to abbreviate the addition property of, and then I write out the whole word, equality. So it says that when you add the same value to both sides of an equation, the two sides remain equal. So, for instance, I'm not going to put this many pieces on, but let's say I had a whole bunch of pieces, and I came up with an equation with a big number to show you, but I just want to show you if I just added 4 to this side, all I have to do is add 4 to this side, and of course 5 equals 5, and now they're balanced. I'm going to show you an equation with a big number just so that you can see indeed it works, even if you can't figure out what the number is right away. So what if I have an equation that says x minus 34 equals 17? I draw the balance scale. I look at the side with a variable. I do the opposite of subtracting 34, which is adding 34. I add 34 to both sides. These cancel out. It's a 0 pair. I get x equals, I got to do some regrouping. 7 plus 4 is 11. I get 51. X equals 51. Now, to check my solution, I'm going to plug in the 51. So down here, I'm going to write my check. I write the equation, x minus 34 equals 17. I put in 51 minus 34 equals 17. I don't want to do mental math. I really want to make sure I got the right answer. So I write out the subtraction problem. If I give you a calculator, that's good enough for me. I'm going to trust that you're doing the math with a calculator, not just looking at somebody else's work. Okay, cool. Next, here's the steps for solving equations. You isolate the variable, right? So I want you to circle the word isolate, and we use the inverse operation. So whatever operation is in the problem, you're going to use the opposite to solve it. It's kind of like undoing PEMDAS. And then you keep the equation balanced using the properties of equality. I'm not going to test you on these properties. I just want you to think about, now I'm going to be doing the opposite. Totally want to use substitution. Underline, check your work. Please check your work. Okay, so I'm going to ask you to pause the video and figure out if you can use your own words to come up with the meaning for the words isolate, inverse operation, and substitution. So maybe you're going to say, the variable alone. Inverse, we're going to say opposite operation. And you know what I'm going to say for substitution. It's that good old Kool-Aid commercial. Plug it in, plug it in. Here we go. Okay, plug it in, plug it in. All right. Okay, so we got some Oreos, and pause the video, try these on your own. Okay, I'm going to underline I'm putting the balance scale down from the equal sign. I'm looking at the side with the variable, and I'm doing the opposite of subtracting, which is adding 8. So I get, oops, I'm going to put 8.0, line up my decimals. I get 9.5, and equals 9.5. When I do my check, I'm going to plug in 9.5. 9.5 minus 8 equals 1.5. And I'm going to do the math. I'm not just going to pretend I know it's equal. I'm actually going to write out the problems, line up the decimal. I get 1.5. So now I know 1.5 equals 1.5 to change. Okay, the opposite of subtracting 1/6 is adding 1/6. I add 1/6 to both sides. I get 4/6 equals 0 pair y. When I check it, I'm going to leave the the answer as 4/6 minus 1/6. And now to show my work, I'm just going to circle the 4 minus 1. I know it's 3. I get 3/6 equals 3/6. Check. Now, here's what I want to do. I still want to take my answer of 4/6 and simplify it. And I get 2/3. So y equals 2/3 is my simplified answer. Okay, so here we go. Decide whether this statement is true or false. The goal in solving an equation is to get the variable by itself. Thumbs up, thumbs down, or sideways. Hopefully you said thumbs up. True. You want to get the variable by itself. Here's the next one. In the solution, the variable must always be on the left side of the equal sign. Nope, we've already seen it the other way around. So you can say that is false. And I'm going to tell you that 1/2 equals y is the same as y equals 1/2. Okay, last one. If you add a number to one side, you should subtract it from the other. Hopefully you know that is false. You have to do the same thing to both sides. Okay. Here is a picture of what the homework problems look like. It is in BIM. They are a lot of multiple choice, but I want you to please write out all of these problems in your math notebook. Write in math notebook. The only way you're going to get better at solving equations is to practice them on paper. Okay, that's it. Good luck.